Well, I'm David Gornoski, and we're excited for this program today. This is a special Science in You episode that we do, and we're joined by two friends that we've seen on our program throughout the years. We have with us our Chief Science Advisor for A Neighbor's Choice and physicist, Dr. Yu. How you doing, Dr. Yu?
Thank you for having me. I'm doing great.
And we also have Dr. Max Fomitchev-Zamilov, who is a recurring guest on our program through the years. How you doing, Max?
Good. Thanks for having me.
And they've agreed to join me. Just I kind of a last minute request as two of my favorite scientists to pick apart interesting information and dissect it and understand it and analyze it. And Dr. Fomitchev-Zamilov, you have a background in computer engineering and nuclear research, correct?
Correct. Yes.
And then Dr. Yu, of course, for those who are familiar with his work on our show, he has a lot of fascinating insights in the world of physics. And we are all excited to be joined by our special guest today, Robert Rucker, who is a nuclear engineer with 38 years of experience in the nuclear industry. And we are going to talk about something you wouldn't necessarily think has something to do with nuclear engineering, but we're going to need to learn a little bit about that. And that's the Shroud of Turin. Right now, this is something that one of the most fascinating mysteries around the world has captured the imaginations for decades and sparked a lot of debate, a lot of intrigue, a lot of questions. And we hope that today Robert Rucker can present their information to give us some answers or some clarity around some of the mysteries surrounding the Shroud of Turin. So thank you, sir, for joining us.
Yeah, glad to be here.
All right. Well, you take it away. Tell us a little bit about why you got interested in this subject matter and how you came into it.
Well, yes, I think it's kind of interesting that my wife and I saw the same little picture in a magazine that came out in the Sunday paper when we were about 12 or 13 years old. She was in San Diego. I was in Wyandotte, Michigan. We both saw it, and we didn't know that we had both seen it until after we were married, and we're just talking about different things. But it impressed both of us. It was only about an inch high and had maybe two or three sentences by it. And the last sentence said, many people believe that this image, and they just showed the face on the picture, could be the burial cloth of Jesus. And I thought, well, that can't be because it'd be so well known, so popular. Why would anyone talk about anything else? I thought. But then I thought, well, I need to be a little bit more open-minded than that. And so in the bookstore, I found a book on the Shroud of Turin, short book, read it. And then a few years later, I found another one, read that. And so it's been a long interest in my life, but it's always sat on kind of the back burner because I was so busy doing other things. I earned a master's degree in nuclear engineering from the University of Michigan and then worked in the nuclear industry for 38 years. When the carbon dating of the shroud was done in 1988, I thought, based upon what I knew about the shroud, I said there must be something wrong with this carbon dating. And about 3 years later, I read the technical article on it. And at that point, I sorted out which laboratories dated which samples. And what it turned out was that the three laboratories that dated the samples right next to each other, the one closest to the small edge of the shroud was the oldest date, and then the next one was more recent, and the next one was more recent, so that there was a linear relationship based upon dependence on the location of where the sample came from, and that shouldn't be the case. If this cloth just was a normal piece of cloth, it should all date the same, but it didn't. So that indicated that there was something going on that was very strange here. And so I thought I knew the answer, but I couldn't do any work on it until I had a computer on my desk that was fast enough and that the computer technology had progressed enough where I could run it on my desk. And then I had to have enough time to do that. And that didn't occur until about 20 years later in 2013, when I actually started working on this project. So I've worked on the Shroud of Turin and presentations on the Shroud since 2013. Now, this presentation took about 3 hours to do when made it at the University of Michigan, and so we only have about half that time. So I'm going to be skipping through this presentation quite a bit, but if anyone has a question, just raise your hand here and I'll try and respond to it. Let's go into the background just a little bit, and let's see. This was the man who took the first photograph of the Shroud of Turin, and the upper view here. It's 14.5 feet long, 3.5 feet wide. The upper view is as you would see it with an unaided eye. The bottom view is the camera negative view, which is actually a positive view. So that what that tells us is that what we see with our unaided eye is actually a negative view, which means that it could not have been a painting from the Middle Ages, because a painter would have never seen a negative image in that time frame. So very strange again. So so if we have a closer look at the front image, we can see the arms coming down. We can see the nails through the wrist rather than the palm, because through the wrist would have bone structure above it. We can see the blood running down the arm from the arm being up in a crucified position. We can see the face. We can see the scourge marks down the front of the legs. The feet then has nails. We can also see water stains on this. When it was in a fire in 1532, they brought it out at the risk of their own lives, and then threw water onto the silver box in which it was located, which resulted in water stains. So we also have two scorch marks on the right and left side, which were formed in 1532 when the fire was hot enough to scorch the cloth that was folded up in the silver box. So on the back image, we have the puncture wounds around the back of the head. We have abrasion marks across the shoulders from carrying a rough, heavy object. Well, on the front image, we have the 2-inch wide elliptical wound consistent with the size of the Roman thrusting spear. And then on the back side, we have that blood then running across the small of the back. And then we have two nails you can see at the bottom of the feet. You'll notice also the feet are rotated together, which indicates that it was under what's the term? After death, the muscles harden in position, holding the feet. Rigor mortis is the term, holding the feet in the position. That indicates he was dead. Also, on the front image, coming down. Can you see my cursor on this or not?
Yeah.
Yes. Okay. Here's the elliptical wound through the body, through the flesh. Here is the blood running down, separated into red corpuscles and clear blood serum. So the bottom line here on these two images is that these are identical to how Jesus was crucified in every respect, which is just amazing. And so a close-up view, 32 power here on the dorsal image, the small of the back. This shows the 3-to-1 herringbone weave of the shroud, and it shows Jesus' blood. So I'm convinced that this is the burial cloth of Jesus based upon the scientific evidence. So that shows his blood right there at the back, the small of the back. So either two options. If the shroud carbon really does date to 1260 to 1390, which is what the carbon dating indicated, then it is not Jesus' burial cloth. But how could the images have been formed in 1260 to 1390? They didn't have the technology to do it. We don't have the technology to form these images today. With all of our laser and computer technology, we can't do this. So how could they do it in 1260 to 1390? Good question. The second option is, if the shroud is Jesus' burial cloth, then the images could have been made in his resurrection. And I think that's where this evidence takes us in our scientific thinking. But why did the shroud carbon date to 1260 to 1390? And with my background in 38 years in a nuclear analysis of nuclear reactors, radiation shielding, and radiation detectors, and knowing the computer technology, the computer codes to run, It's almost like I've been ideally selected and channeled through life to solve this problem. And I think I have. And so there is also not only the Shroud of Turin, but there's also another cloth called the Sudarium of Oviedo, which we believe is the face cloth that was mentioned in John 20, I think it was verse 7 or 8. And this was a smaller cloth, about 33 by 21 inches, does not have an image on it because it was separate. It was not on the face at the time of the resurrection. It was separate from the body cloth and not on the body. But it has a pattern of blood and other stains that are consistent, we believe, with the stains on the Shroud of Turin. All this is just amazing. So just very quickly on the history, this is believed to be the route that was taken. At least most shroud researchers would agree to this. So that we have different locations that give evidence that it was there. Where I put in dashed or dotted lines, we don't have the route, but we still have the evidence for these different locations. So that it was taken from Jerusalem up to Antioch on the coast, and from there taken on various missions. We have a reference, I think, in Galatians 3:1 to this cloth being used for apologetic and evangelistic work up in Galatia. Very interesting. And then it either went by a water route, or some people believe it took a land route to go over to Lorraine, France, where it was shown as the burial cloth of Jesus in 1356 or so. And so let's see. Okay, so that on the cloth, there's the face, the detailed face of how the face looks, and you can see, I think, the teeth, which a good indication there. Something had to carry the information from the body to the cloth in order to encode the teeth onto the image. So whatever it was had to come from the body, go across the gap, the air gap, until it was deposited on the cloth. Okay, and so that this image then, according to tradition, it was hidden due to persecution in a niche above a gate in the wall, probably in Antioch. It was then discovered probably in the early 500s. It was probably in that hidden location for 300 years or so. So when they found it, then they knew what Jesus looked like, because before that, his paintings of him, a lot of them were showing no facial hair at all, no hair, no beard, no mustache, because that's how the emperor looked. But when they found this cloth in the niche above the gate, then they could make paintings. This is the first painting, about 550, maybe up to 600 AD. It's called the Christ Pantocrator, which then was this concept, this image of what he looked like, was transferred down Byzantine iconography till it came into our concept of what Jesus looked like. So our concept that most people have of what Jesus looked like came down to us through Byzantine iconography based upon the image that was on the Shroud of Turin. In other words, long nose, large, deep-set eyes, hair parted in the middle, hair a little longer on one side than the other, mustache, beard looking straight at you. And that's how the image looks on the Shroud of Turin, and always down through Byzantine iconography till it came down to us. So it's been on coins starting about 692 to 695. I have this coin. On the back of this coin, just to clearly identify who it was, on the front image, it says in capital Greek, Jesus Christ, King of Kings. So it clearly identifies. So his image was very well known, very prominent, because it was on their money. And the emperor realized that this was so significant that he took his image off the money and put the image from the Shroud of Turin on the money and identified clearly who it was. So yes, this is all statistically significant before the carbon dating of 1260 to 1390. we have various sermons in Latin. We have colored line drawing from a period of 1192 to 1195. The top image shows the three men, John, Joseph, and Nicodemus. Then this is Jesus, clearly identified by the nature of the halo, or a technical term would be nimbus, a nimbus around his head. The bottom image shows the burial cloth with three different holes showing in an L pattern. I'm just skipping forward quickly here. There it is, a little bit better view of the three holes shown on the folded top piece of the cloth. There it is again, the three holes. And so that these three holes show on four locations on the image from the shroud. If you bring the four different items together, what you probably have here is someone bent over a little bit too far with hot coals in his censer, and they fell out onto the folded cloth, burned through this, then this, then this, then this in sequence. So that what is shown on the Pray manuscript, and his last name that discovered this his name was Pray, so that this really is referring to the Shroud of Turin and disproves the carbon dating. So we have various different evidences that, and we have, in his biography, Robert de Clary said that in 1203, there was another of the churches, which they call My Lady of St. Mary of Blachernae, a district in Constantinople, where there was the shroud in which our Lord had been wrapped, which every Friday raised itself up so that one could see the image of our Lord on it. In Constantinople, they loved to have little gizmos that would do special things. So there was probably a man underneath the podium working the pulley system to pull the cloth up every Friday to show everyone. Fascinating. So it was shown here about 1355 or 56, finally came into Turin, Italy, and is now located in the cathedral in Turin, Italy. It came in there in 1578. On the 400th anniversary, they opened it up for a showing. There's usually only 5 or 6 showings of it a year. Or you should, but this is the 1978 exhibit of it. And so let's go into testing. It was tested by a group called the Shroud of Turin Research Project. This is showing one of their planning meetings, who were then invited to come to Turin, Italy, to do 5 days, 24 hours a day of non-destructive testing on the Shroud of Turin. And so there was 26 different individuals. This is the leader, John Jackson, PhD in physics. And they brought all of their equipment with them. They had 26 different individuals that went. Their conclusions here after 5 days, 24 hours a day of doing scientific testing on it, the images, and their main goal was to determine how the images were formed. So the image is not due to paint, dye, or stain because there's no pigment, no binder, no brush strokes, no clumping of fibers or threads, no stiffening of the cloth, no cracking of image along the fold lines. And it's not a scorch because when they turned out the lights and brought up black light, it didn't fluoresce. You know, the scorch marks did fluoresce, but the image did not. It's not a photograph because there's 3-dimensional information in the 2-dimensional image on the shroud. It's in the category of satellite telemetry data. Absolutely fascinating. There's no normal photograph or a painting that contains 3-dimensional information, but the Shroud of Turin does. It's also not a scorch from a hot object. It doesn't fluoresce. I said that. The image is not due to any liquid because there's no capillarity. So how was the image formed? We can see it. You know, why can we see it? How was it formed? Science should be very interested in this because what you see here, this is a close-up view, 34 power, 64 power, and this is where the image is the strongest, the tip of the nose. But you don't see the image. You have to stand back about 8 feet in order to see the image. But what you see here is just a discoloration on the fibers. It's just the top two, maybe three layers of fibers in the thread that are discolored in this kind of straw yellow, or sometimes called sepia color. And that's what's forming the image. Absolutely amazing. What is it that could have discolored the fibers in this fashion to form the images, front and back, full-size images of a crucified man? And so probably one of the hardest things to explain is that the discoloration in the fiber. Now, a fiber is 1/5 the diameter of a human hair. This is a flax fiber from the flax plant. But the inside is not discolored. It's only discolored with a very thin region all the way around the outside. And I listed here as less than or equal to 0.2 micrometers. In my further research, I think that it could probably be better be said to be between 0.2 and 0.6 micrometers. Now, that's about the width of a wavelength of light, if you can imagine this, so that there's absolutely no capillarity because the inside is not discolored at all. So how in the world was this image formed? And so their final report, we can conclude for now that the shroud image is that of a real human form. They could tell that a real body had been buried in the cloth based upon the nature of the blood that's on the cloth. Human form of a scourged, crucified man. It is not the product of an artist. The blood stains are composed of hemoglobin and also give a positive test for serum albumin. So they are real blood. So the results of the carbon dating. Now, so they cut the sample from the far left-hand corner here as it's held horizontally. Of course, they didn't want to cut it from the image. They wanted to cut it from an area far from it. But you can see the discoloration here, probably from the handling, because that's the area where it was always held in the displays. Question?
Is this the top cover? The image is the front face. So is this the fabric is on top of the cover?
Yes, this would have been on top of the body.
Okay.
And to the right of this is the section that was below the body. Yeah, so this was on top of the body. Okay. And so there's a picture of them cutting that sample from that location, from that corner. So this is my drawing of how that cut took place. Now, you might see up here, there's a seam along here, and that seam is important because there's a unique stitch that's most similar to a stitch that has only been found on a piece of cloth from Masada, which was destroyed in 73 to 74 AD. So this seam dates the shroud to the 1st century. There's about 16 different other dating techniques other than carbon dating on the Shroud of Turin. And the seam is one of them. But what you see here is that this corner and the other corner way down in this direction on the backside, it's torn off because they would hold it along there, and that's where the stress on the fabric would be highest. Okay, so that's the backing cloth. So what I show here, this is the backing cloth. Okay, this is the side strip. The seam is along here, but this is the cut that was made. So they cut off a first piece to go to the laboratory in Arizona, about 35 milligrams, cut another piece about 52 milligrams to go to Zurich, and then another 52 milligram piece to Oxford. They then realized that this piece was a little bit smaller than the other, so they cut another piece. It was probably actually cut from the far end of this. I need to change this diagram, update it a little bit. But those samples were sent. So this is cut actually from the Shroud of Turin, from that corner, and they went to the 3 different laboratories right next to each other. So it was published, results were published in Radiocarbon Dating of the Shroud of Turin. The first author was P.E. Damon, so we often call it just Damon, but there were 20 other authors that were allowed to put their names on it as well. And that was published in the journal Nature on February 16th, 1989. Now, their conclusion was the results provide conclusive evidence that the linen of the Shroud of Turin is medieval. I think that conclusion is totally wrong, and we'll get into the reasons for that. Now, for example, a peer reviewer of this paper, Professor Bray, recommended deleting this conclusion, but the editor of Nature decided to include it anyway, so that one of the peer reviewers wanted it removed, but it wasn't. So this is the statement that's come down through the media to us. Okay. So I go into statistical analysis here a little bit, but and just in what we mean here by 1 sigma. So in any experiment that's done, you get a range of values due to variation, random measurement errors. So that this area here would be called just a 1 standard deviation. About 68% of the values fall into that. And then we have 2 standard deviations and then 3 standard deviations. But the data here with the 1 standard deviation uncertainty is listed for the 3 laboratories, Oxford, Zurich, and Tucson. And I'm listing them here from closest to the small edge of the cloth, then in the middle, and then furthest from the small edge, closer to the center of the body mass. And what you see here is 1200, 1273, 1303. So you see that the dates are increasing as you go up. In their analysis that was published, they just took all of these values and took the mean value, and they published 1260. Now, when I do the analysis using a normal or Gaussian distribution, I know how to do this calculation. I've done it many times. And I come up with a different value, 1277, plus or minus 12.6. Now, there's some difference here. I think they were using a t-distribution to come up with the 1260 value. But you notice the huge difference between 31 and 12.6. There's significant questions about the validity of the statistical analysis that was done. And there always has been since that paper in Nature has been published. Okay, so for example, 2 of the laboratories were statistically different in the value that they obtained. And they were different by a value of 2.96 sigma value. Now, some of this is a little bit technical, but those who are listening to me that are technical know exactly what this means. And so these are the dates. And if we plot the dates at the center of each sample, and here's the 1200, 1273, 1303, then you get this result. And you see here that the red values that are plotted, that's the average, and the range is the 1 standard deviation. But what they did was that they just took the average of the 3 values, but you notice that only goes through one of the experimental values. 2 of them miss it entirely. So the slope that actually goes through this is the best fit line, the line that minimizes the difference between the experimental values, gives us a slope of about 36 years, and that's the value, the exponent on the x value, or the coefficient on the x value, about 36 years per centimeter, or 91 years per inch. So if you move the sample point up 10 years, you'd get a carbon date to the future. That's my prediction, okay, based upon the evidence that we see here. So I don't want to go into all of this, but one of the key takeaways here is that the normal criteria for acceptance in a statistical analysis is a significance level of 5%. Now, I've never really understand that. I'd much rather have a 95% statistical analysis value, but they use 5%. And so what did they come up with in their analysis? Lo and behold, material 1 was the shroud, material 2 was the 3 different control standards. They came up with, lo and behold, 5%. Well, what did I get in my statistical analysis using a normal or Gaussian distribution? 1.4%, which then, if you came up with a 1.4%, then you would reject the data, because that would indicate the presence of a systematic measurement error that was taking place in the data, because the values don't agree with each other within their uncertainties. And when they don't, it indicates the probable presence of a systematic error. You notice on the control standards, we have 90%, 50%, and 30%, way higher than the Shroud of Turin values. Very, very interesting here. So here we go. This is my analysis of 1.4% on the significance level. You notice up on the average value for the measurements in Tucson, I calculate 17.05, whereas the published value in Nature was 31. Huge difference. Okay, wow. So how in the world, what is the date? Well, it was interesting that the British Museum did not publish the detailed data on the carbon dating of the Shroud of Turin until they were forced to do so by legal action. Finally was published made available in 2017. I believe that's correct. And so at that point, then 4 different papers were able to be done, published in peer-reviewed journals, that all concluded that the dates on the Shroud of Turin should be rejected because the values are heterogeneous, they're not homogeneous, which means that they did not agree with each other within the uncertainties. Okay, so we have good scientific basis for rejecting this. Okay, so all the different ways, evidences that contradict the 1260 to 1390 date. So on this plot here, the time of Jesus would be about 33 AD. This would be the time of Jesus. Up here would be the carbon date with the uncertainty. We've had 5 different measurements in the last few years based upon new scientific technologies to date fabric. And I think there were 4 different methods used. But you can see here that there's fairly good agreement with the actual time of Jesus with these modern dating techniques, and they do disagree with the carbon date. The most recent that maybe people have heard about is the Waxus value, which is in close agreement with the time of Jesus. And this is wide angle X-ray dating technique. And so this is a very interesting development. So any questions on all of this at this point?
No.
No. Okay. Okay. So the date of 1260 to 1390 should be rejected. And then I interviewed a man. He flew out from Turin to Ann Arbor, Michigan, and I interviewed him there because he's very familiar with the Shroud of Turin. And this is the box that you see here. This is where it's located in the front left-hand corner of the cathedral in Turin, Italy. I was able to take a picture of this in November of 2023. Okay, so we have many different problems, and we won't have time to go through all that, but what we need to do is to actually explain how carbon dating could come up with a date of 1260 to 1390, because the equipment that was used in that test to measure the ratio of carbon-14 to carbon-12, I believe, would have measured the correct ratios of the samples that were provided to them. So once you say that they calculated the correct ratios of carbon-14 to carbon-12, then how could they be wrong? Let's go into it. Okay. Different ideas have been proposed to explain it. What I believe is the correct explanation is neutron absorption on the cloth. And this was proposed, for example, by Tom Phillips in 1989, actually in a letter to the editor in the same issue of Nature that published the data from the carbon dating. But I find it was actually discussed before Tom Phillips even. Okay, so there's 3 ways to produce new carbon on linen. One would be carbon-13 absorbs a neutron, goes to carbon-14. Another is carbon-14 absorbs a neutron, goes to carbon-14 plus a proton. And then third is oxygen-17 absorbs a neutron, changes to carbon-14 and kicks out an alpha particle. But significantly, this second item produces about 96% of the new carbon-14. So that's the one that I focused on. I pretty much ignored the other two. So here's the hypothesis that I have for explaining why the carbon dating was different from the three different laboratories than 30 or 33 AD. So that the carbon date was not consistent with the historical date of Jesus. So my concept is that neutrons were included in the burst of radiation that caused the images. In other words, image formation and shifting of the carbon date are related. They were both caused by the same burst of radiation. A small fraction of these neutrons that were emitted were absorbed in nitrogen in the shroud to produce new carbon-14 atoms in the fibers by this reaction. Nitrogen-14 plus neutron goes to carbon-14 plus proton. And this caused the shroud to be carbon dated younger than its true age. This would be the source of the systematic measurement error that I mentioned that altered the ratio of carbon-14 to carbon-12 in the samples. So even though the ratios were measured accurately in the carbon dating, the date that was produced was still wrong. Isn't that interesting? And the reason is because when you get the correct ratios of carbon-14 to carbon-12 for the samples, you then apply standard equations to calculate the date. But those equations make an assumption. The assumption is that the carbon-14 to carbon-12 ratio has only changed due to decay of the carbon-14. Well, in this case, new carbon-14, I believe, has been produced by neutron absorption so that those equations no longer apply to the ratio of carbon-14 to carbon-12 to calculate the date. The equations don't apply. Let's move on. So I used a nuclear analysis computer code called MCNP. And this is an industry standard nuclear analysis computer code, fully verified and validated to regulations put out by the Department of Defense and the Nuclear Regulatory Commission. And so the acronym is Monte Carlo N particle, where N stands for neutrons. So it was initially designed a couple decades ago to just handle neutrons, but then they put in all the other coding and data required to run many, many different particles, including photons, including protons, including exotic particles, so that this is the standard computer code that's used for designing nuclear reactors and anything else. And so, so that every time you design a nuclear reactor and you run it, you get the right answers. It agrees with your computer code, so that all that validates the computer code. And we have thousands of experiments in nuclear facilities have been validated with this computer code. It's a reliable computer code. So what I did was that I put into my model I put into my MCNP model the limestone with 3 different benches in the tomb, and that would be a left bench, a right bench, and a back bench. I put modeled the body on the back bench, surrounded by a linen cloth above and below, going over the head. And then the most likely place for the face cloth to have been dropped, because they would have left the face cloth on the body while it was transported. If it wasn't covered by face cloths, you would have used something to cover the face at least during the transport process to the tomb, so that they'd bring the body in, lay it down on the bottom half of the cloth. Then the person doing the burial would reach over, take the face cloth off, and absent-mindedly just drop it on the right bench, 15 to 18 inches in front of the back bench. That was my prediction. Okay, so I think we're not told in the Bible where it was dropped, just that it was separate from the body cloth. But I think you can make a pretty good prediction, and that becomes important. Okay, so this is my model, side view of the model with my body on the back bench surrounded by floor, wall, and ceiling of limestone. This is top view of the body with the entrance and the circular stone that was rolled in front of it. So that my calculation, when I assumed that neutrons were emitted uniformly or homogeneously in the body, they would then exit the body, maybe 60 to 70% of them would exit the body, go across the air gap through the linen cloth, across another air gap into the limestone, bounce around about 150 times, come out with a characteristic distribution of neutrons, which then produced this curve, predicted curve, of carbon date on the cloth below the body. And so this is the y-axis is carbon date. The x-axis is the distance along the midline of the body with the 0 point, at this point on the body, so that the samples were actually tested down at this point, the second point from the bottom on my calculation. But this point would have a slope across it, as you see here. Okay, but this slope, let me go back here, is very close to the same slope that we saw in the experimental data here. So in other words, my computer code is producing a slope that's consistent with the laboratory measurements. Isn't that fascinating? Question.
If I may. So what caused the neutron production within Jesus's body?
Yes. What you have to do is you have to follow the evidence where it leads. And that's the key. Rather than making presuppositions that rule anything out, you have to keep everything flexible. And the result here, the scientific conclusion here, is that the root cause, as far as I can track it back, would be a vertical oscillating up and down vibration of the nuclei in the body. Now, I say that with a straight face. I know that's outside of our current understanding of the laws of physics. But in order to, yeah, go ahead.
Can you clarify what you mean? Because I don't understand what you mean by vertical oscillation of nuclei within the body. What is that exactly?
Yes, what I'm saying is that the nuclei, every atom in his body would have had a nucleus at the center of the atom. What I'm saying is that those nuclei went through a vertically oriented oscillation, up and down, extremely high frequency, perhaps over a microsecond or a nanosecond. I haven't calculated how rapid it was, but within that, let's call it a microsecond. Within that microsecond of pulse, there was this oscillation frequency of maybe a nanosecond. And again, I haven't calculated that yet. I think there is a capability to determine the frequency of that oscillation, and I think I can get you to that. But so I'm talking. I have to go outside the box here in my thinking in order to explain the evidence that we have from the Shroud of Turin.
Do you mean this emission of neutrons by spontaneously, some kind of disturbing from external environment, spontaneously emission? What's the cause? Yeah.
Yes. What's the root cause? The only root cause that's consistent with any of our understanding in reality is the resurrection of Jesus. That's the only possibility, because no dead body emits a burst of radiation that forms an image of itself on fabric. We have no example of that. So in order to explain this, we have to go outside of our normal assumption of that everything has to happen naturally, an assumption of naturalism. We have to go outside of an assumption of naturalism in order to explain the evidence. So we have to let evidence be our guide here. We have to follow the evidence. There are no other suitable explanations than radiation from the body. And the main researchers on the Shroud agree, the four main researchers on the Shroud, the main hypotheses that have been proposed, all propose in various ways radiation from the body formed the image. It's absolutely amazing.
Based on the resurrection, which happens after like 3 days, Jesus died. So
Yes.
that would be started from zero, right? Year
Yes.
one.
Yes. No. What? See, the evidence on the image itself. If you look at the fiber thickness, and I mentioned that the thickness of the discoloration is about 200 to 600. What was it? Micrometers, about the wavelength of light. Now, in order to do that, you had to have heat deposited just in that extremely thin region, and you had to have the heat deposited extremely rapidly, because if it was deposited over a long period of time, it would have spread by conduction into the inside of the fibers and thus discolored it, but it didn't. Okay? So this is absolutely amazing what we're talking about here. Now,
Because you're saying the only discoloration is on a superficial level of the fiber, right?
yes, superficial, yes. Exactly right. It's only the outer 2% of the volume of the fiber, and the fiber's just 1/5 the diameter of a human hair. So, I realize in talking to technical people, this is so shocking that it leaves you speechless, where I had to go to explain this. So in other words, what I'm saying here, we can determine. So what I'm saying is that the neutrons were emitted from the body. They slowed down in the limestone. About half of them would have come out of the limestone, formed a characteristic distribution in the tomb, so that the carbon dates of the three laboratories were different because they were at slightly different locations across the shroud, thus absorbing a different number of neutrons, thus producing a different number of new carbon-14 atoms on the cloth, thus giving different carbon-14 dates. So it all fits the evidence. That's why I've been working on this for 11 years. So in other words, we can determine. So the only other option is that if this really is due to Jesus' resurrection, well, when would that have been? Well, usually either 30 or 32 is chosen. I prefer 30 or 33 AD. So the neutron absorption would have shifted the carbon date by production of new carbon-14, would have shifted the carbon date from 33 to about 1325. That's the average of the carbon date of 1260 to 1390. And so I can calculate how many neutrons have to be emitted from the body. It's about 2 times 10 to the 18th neutrons, based upon my nuclear calculations. Well, you say, well, that sounds like a terribly high number. Well, it really isn't. The number of neutrons in the human body is about 2 times 10 to the 28th. That'd be 2 followed by 28 zeros. So it's only 1 neutron for every 10 billion neutrons in the body have to be emitted from the body in order to shift the carbon date from 33 AD to 1325 AD. The carbon 14 concentration only has to be increased by 16.9%. So that this would require only, so where do the neutrons come from specifically? Well, they have to come from the nuclei that were oscillating. And when you start asking that question, which nuclei would require the least energy to split? The answer is deuterium. Now, deuterium is another term for heavy hydrogen. It's hydrogen that contains a proton as well as a neutron. So what I'm saying here is that if you had 0.0004% of the deuterium or heavy hydrogen nuclei split in the body due to this vertical oscillation, you would emit enough neutrons to shift the carbon date on the 3 samples that were dated from 33 to 1325 AD. Any questions on that? That's the carbon dating. And I realize that this is thinking outside the box. I realize that. But it's interesting that my results have been confirmed to an extent by comparing my measured neutron absorption on different sections of the cloth against photographs taken in 1978 of the fluorescence from the shroud. So there's been a degree of confirmation on these measurements. So, for example, there's greater fluorescence on the right side than the left, just as my calculations predict. It's greater on the right because that's where the wall was, which reflects more neutrons. On the left side of the body, you'd have just the air in the tomb, which wouldn't be reflecting neutrons. The fluorescence is greater below the body than above the body. So that my prediction is that the cloth under the body would absorb more neutrons because, again, they're being reflected by the limestone, and that the fluorescence is greater over the center of the body, in excellent agreement with my calculations. So in these 3 senses, we do have a degree of fluorescence, of confirmation. No, I say a degree because there were problems in the photographs that were taken of the fluorescence in 1978 because you have these different burn marks and you have the watermarks and whatnot, and then the different stains from the high temperatures. So anyway, but you have a question.
Yes. So the purpose of your carbon dating is try to identify which year Jesus died. Is that the purpose of your carbon dating?
Well, so what I've done here, everyone would, due to the media's influence, would simply take that the shroud was a forgery in some sense because it dated to 1260 to 1390. So
Okay.
I'm saying that the vast majority,
Right.
we have 16 out of 17 date indicators that say that's not true.
Okay. So basically what you're saying is you try to identify this shroud is true from Jesus.
Yes, I'm trying. Yes, I'm
or
trying.
not from Jesus. Okay. But
Yeah.
now all the evidence you have previously by carbon dating, so they all dated it like what is it, 1360 to something later.
Yeah,
That
1260
means
to 13.
if that's true, then this shroud should not be a cover of Jesus' body, right?
Yes.
And what you try to argue, say, hey, you identify the oldest, a different location on the shroud, and give the oldest date. Is that what you accomplished? Which point to the year 1, year 0 of Jesus
Yeah. So that you have about 13 or 14 different date indicators, which give you an upper date limit.
Okay.
That contradict the carbon dating. So it has to be younger than those. Now there are some like the stitch on the seam gives you a date to the 1st century, for example. And then
Okay.
I'm trying to get back here so that.
And your results agree with the earliest one evidence?
Okay, so I'm trying to get to my where is it? I don't know where it's gone. I'm sorry. I was going to show you the plot of how the various dates fit in.
Yes,
Again. So there were only two options. This was on one side, two options. Either the shroud dates to 1260 to 1390 in agreement with carbon dating, but that contradicts 16 out of 17 data indicators. Or the shroud is Jesus' resurrection, because you have to be able to explain the image in some way. Okay. And so the only other option is Jesus' resurrection. Gives you options to explain the image formation. And so on my MCNP calculations, the output from MCNP is normalized to 1 neutron. I might run 30 million neutrons in my calculations. That's what I was running. But it normalizes everything to 1 neutron. Then I have to renormalize it. So what did I renormalize it to? Well, the only thing I had was the carbon dating that was done. So I wish I could. I'm sorry. I'm sorry. So on my plot, I showed the second point from the left on the curve that went up to show the maximum date of about 8,500. I'm looking here. Oh, right here. So that this point is the location where the sample was cut that was sent to the 3 laboratories. So I normalized that point to their data. So I do not get credit for this point being of any significance, because I normalized the whole curve to that point. But I do get credit for producing about a very similar slope to the curve. That's just one data. The other thing I think I get credit for is that, well, let me move ahead a little bit further. There's actually 4 different evidences from carbon dating, not just one. The first one is the mean date of 1260 to 1390. The second is the slope to the curve of about 36 years per centimeter. The third is the range and distribution of the 12 subsamples that were dated. The fourth is the date of the Sudarium. That's the face cloth of Jesus. They carbon dated that to about 700 AD. And you remember I predicted where it would be located on the right side of the bench. So up to that point, I had not been including linen on the left bench or the right bench. But at that point, to calculate the date for the Sudarium of Oviedo at my predicted location, I put those linen cloth into my model. And when I get the results back out, the results that I got from my predicted location on the right side bench, about 15 to 18 inches in front of, toward the entrance of the back bench, the calculated value was about 700 AD, plus or minus 50 years, which was in agreement with the laboratory experiments. Now, that's what science ought to be about. You come up with a hypothesis and you make predictions. And if your predictions are false, then you know that your hypothesis is false. But if your predictions turn out to be true when tested, you gain credibility in your belief in your predictions. That's how science works. Okay?
Your prediction is much improvement than 1260. Your prediction is 700. You're talking about something, and it's much earlier than 1260. Something predicted by other evidence. So you got a lot of improvement, but it is still short of.
No,
Okay.
no. Yeah, I was exactly on. What I'm saying here,
Oh,
my calculation predicted the neutron distributions in the tomb. You know, the neutrons were being
uh,
emitted by the body, so that as the location is further and further from the body, the neutron intensity or concentration goes down. So what the computer code predicted, 15 to 18 inches in front of the back bench, was a carbon date of 700 AD. Now, if the Sudarium was dated to 300 AD, my prediction would be totally wrong. But it wasn't. It was exactly on. And that's how science works. You make a prediction, you do the test. If the test turns out to be true, it doesn't necessarily prove it to be true.
oh,
So science is mostly about evidence rather than proof. But if the test proves out to be true, then you gain in your confidence in the credibility of your hypothesis.
can you explain a little bit why you predict this shroud is from 700 AD? Why this is right why correct this is covered on Jesus, body?
Yes.
How do
So
you why it's on? Why missed by 700 years?
uh, why? Because the neutron concentration diminished as distance increased from
Okay.
the body.
Right.
So in other words, you see this curve right here? Now this is the curve of the carbon date. That's what I'm displaying here. But it's also the curve of the neutron distribution across the, you might call it the X direction, along the backbone on the dorsal side of the body, on the back of the cloth. Okay, along the dorsal or back image of the cloth. This is the neutron distribution
Okay.
that's shown by the calculation, and that
So
just makes sense, because with the neutrons being emitted from the body, you would have the highest neutron concentration at the point of the body. Now, this entire distribution was actually underneath the body. I don't want you to misunderstand that. But I
okay.
had to display it here where the carbon date was coming up higher. But it was actually along the center line below the body on the dorsal image.
Okay.
The,
So
so
you
the
predicted
extraordinary event that created.
yeah.
Okay, go ahead.
Oh, you say you calculated this is 700 AD, but actually you can back based on the concentration of the neutrons. So you can back calculate it.
So what I calculated here was that the date for the face cloth, which was set in front. You remember, I set this a distance from the body, and that was my prediction, that the face cloth was set. Most people are right-handed. It would have been dropped on the right bench, and his body, it probably would have been dropped right even with where his body was standing. So that's where I predicted that the cloth would be located. So then I do the calculation. The Shroud of Turin then dates to 1000 AD up to 8500 AD. That's what my prediction for the shroud is. They happen to take the sample from a place that dated from 1260 to 1390. But my prediction is it would date from about 1000 to 8500 AD, well into the future.
Because of the extraordinary event that you hypothesized took place to create the unique image characteristics on the shroud. That's
Yes.
where you get that date range. Okay.
Yes.
You understand
Yes.
what he's saying, Dr. Yu?
Yeah. So
That extraordinary event is what creates that date range that goes out like that. Because
So
yes.
So this curve is normalized to this value, because that's the only value that I had to normalize to That's the experimental value. The rest of this curve is calculated by my computer code. Okay?
Yeah.
Okay?
Based on the different location, you calculated this curve,
Oh, yes.
predict the dating different year. Yes, I haven't, yeah, I have no problem with that.
Yes.
Just one thing I do, slightly different than what you said about there's emission, so radioactivity, the emission of neutrons. I do not believe this just in the event. Due to resurrection event can emit neutron. I do believe emitting neutron could be spontaneous. That's radioactive decay could happen naturally or environmental difference. It could have a constant emission of neutron. So that could be a little bit, give you maybe a
Yes.
little bit different predicted year, dating year.
Yes. But you have to stop to think about what that would do to the evidence. That would not be consistent with the evidence. It would not produce discoloration just all the way around the circumference of the fibers that's only as thick as the wavelength of light. You have to be able to explain the evidence, and your concepts there are not consistent with the evidence. All those have to be rejected.
Oh, the dense.
Sorry to interject. I gotta go in just a minute.
Yeah, yes, and I think we're about an hour and a half into this.
Yeah.
Yeah,
And
do you want to stop at this point and continue later?
Yeah, because I have to go. But I wanted to say that this is interesting presentation, and I understand, the point of your theory, of your idea.
Yeah.
And miracles aside, I think it's a valid point. I don't know what could have caused emission of neutrons, from within Jesus's body, but to me, sitting in and listening to your presentation, the data makes sense. The only criticism I would make is, 3 points doesn't seem like enough to really stake a case that there is like a linear change in dating throughout the shroud, but that's not a fault of yours. There's just not enough samples. But to me, that's the critical, well, I guess, weakness of this whole idea. If they were, more data points, would be easier to argue that the carbon dating really changed depending on the location of the shroud. But 3 points isn't really enough, in my opinion. So,
yes. Well, I have more than 3 points. I have 4 points. I also have the Sudarium of Oviedo.
well, it's a different material. I mean, it's a different artifact.
Yes, but I can explain it, and other concepts can't.
Well, I'm saying, your presentation is interesting.
Yes.
That 3 data point shroud
Yes.
is
So-
weakest
so-
point of it.
Yeah, so what I'm doing now, I mentioned that there's 4 different evidences. My concept is consistent with evidence 1, 2, and 4, but not 3, which is the 12 different dates for the 12 different subsamples. And that's what I'm working on now. And it'll probably take me 6 months to do those calculations.
Okay.
So then I'll have 12 points in addition to the 4 that I already have.
Yeah, but I'm really happy I got exposed to your research,
Mhm.
and we can talk some more about it. But David, I'm sorry, I gotta go. This has
Thank
lasted
you.
a little longer than I expected.
Thank you, Max. I appreciate you coming on.
Yeah.
Thanks. It was a pleasure.
Yeah.
Okay.
So,
Thank you.
shall we stop at that point then?
Yeah.
I
wrap
still
it
have a
up.
question.
Yeah.
I still have a question here. So these images are visible to naked eye? So you
Yes.
shoot a picture or use electromagnetic device to come out of this image.
Yes, they're visible to the naked eye. That's why when it goes on exhibit, you usually have about 2 to 3 million people file past it to see the image.
You just went past it, though.
And that shows the people. You can see the people lined up here. Why are they lined up? Because you can see the image.
Okay.
No, because you can see the image. It's there. Now it's not real dense as I showed you here.
Yeah.
In other words, you can't see it real clearly here. It's more visible with when looking at a photograph, because the photograph by its very nature enhances the contrast
Okay.
so that you can see it here better.
Do you see the naked eye version on top, and then the
Yes, here's the
negative
here's the
image?
naked. Yes, here's the
Do you see
naked
it on the
eye.
image, Dr. Yu?
It's right here. Here's the face front, and here's the back of the head. Here's his arms coming down.
Can you see it?
Here with the blood coming down. The blood is actually coming down in two different patterns, because he had to be pushing up and down during crucifixion, which would then change the angle of his arms, and that was picked up by the blood flow on his arms. We're looking at the authentic burial cloth of Jesus.
Can you
I
see
have
the image, Dr. Yu?
yeah.
Oh, yeah. Okay.
Yeah.
So,
Yeah.
So the brown one is the naked eye image, and then this X-ray looking one is the inverted image.
Yeah.
photo image seems like give a little bit more detail to it.
Yeah. So you
that's
can see
agree with you.
you can see the two different angles of the
Yes.
blood flow here.
So the question is, how did that occur in that way? Is the
Yes.
question.
I have no problem. I agree with your methodology. I believe the methodology you use is more accurate than all previous predictions. I have no problem with that one. But I was just thinking about the emission of a neutron. It's not just like by a single event, say resurrection or somehow. I believe this could be constantly emission due to some kind of spontaneous event or environmental something emission. And the reason we see different some shallow color or some kind of darker color is because different density of a body. Of course, different density of body. So then emit a number of the neutrons and create the imprint on the fabric will be accumulated, will be more than less density, like more like a flesh part instead of a bone part. So that's why. But this image, I believe, formed over years. It's not like a single event. That's the only thing what come to my mind.
I know that idea is not consistent with the evidence. As I said, the thickness of the discoloration on the fiber forces you, once you consider that properly, forces you to believe that this was a extremely rapid burst of radiation from the body. Now, please don't misunderstand me. I'm not saying that the images were formed by neutrons. We just didn't have time to get into it. The deuterium splitting of the deuterium nuclei would release protons and neutrons. It was the protons that formed the image. The neutrons shifted the carbon date. They had two different functions. They were all emitted at the same time.
I'm not arguing that one. For me, this is all electromagnetic image, and formed by you may some kind of spontaneous emission of particles. And why these particles are changing the color. Part of the physical impact, right? And part of the because every particles, all the fabric, they have a electromagnetic property and could be imprinted with this image, different, magnetic, density, magnetic image, magnetic field, the intensity. You could be many different things. And this property, you're talking about we're talking about the neutron or protons. So in my mind, so these are all those kind of all made by charged particles. Even neutron is a part of particles too. So it's not necessary. One part is probably from imprint or from absorption those particles and create the different density and create different coloration of the images. That's all possible. And for me, these kind of things accumulated over years. Could something could over years, something could be instantaneously happened that way. I'm not denying that possibility.
Yes, I think I've already answered that question.
Yeah, that's all
Yeah.
right.
Could I just talk for maybe a minute or two about the image formation
Yes,
concept?
go ahead.
Yes, okay. So that what I'm saying is the images were not formed by radiation damage. Okay. What I'm saying is that the protons were emitted vertically because of the vertical oscillation of the nuclei. They were emitted oscillating between vertically up and vertically down so that the front and dorsal images were formed simultaneously, and that they were formed not by radiation damage, but by the electrical charge on the protons. When they were deposited on the cloth, they caused an alternating current in the fibers because this was going upward, downward, upward, downward. So it would have the charges being deposited on the top and bottom cloths relative to his body would have formed an alternating current. Now, an alternating electrical current is interesting because what it does in your wires in your home here, an alternating current, when you turn on the electricity, that alternating current will cause oscillations in electric and magnetic fields, which cause the electrons to flow only in the outer region of the conductor. And that's what I need to explain the
Yes.
discoloration only on the outer part of the fiber. Something, it has to be caused by something.
Right.
And the only thing that I know of that can cause the fibers to be discolored in that location is an alternating electrical current in the fibers.
The different color comes out of different oscillation frequency. So in this case, so whenever we have a radioactivity case, or you have emission of particles, accumulation of particles. So you're changing the density, and whenever you're changing the density, I'm not necessarily you have to damage the fiber. Okay, you accumulated, so you have a different density, and the different density forming different oscillation frequency. So that's why I give you different coloration. So it's not necessarily damaging the fabric, but the coloration comes is all because of different vibration oscillation frequencies. That's what color is, right?
Okay, so what I'm saying here is that the electrons being forced to the outer radius, just around the circumference on the fiber, the outer radius by the alternating current, that's where the heat from the electron flow would have been deposited, so that the discoloration is due to a scorching due to the heat.
Yeah. Where comes the heat? This oscillation create the heat. Of course, the scorching. So when you create the heat, you have a scorching. Basically, you said that the fabric is damaged somehow. You create the heat, scorching is damaged somehow. Actually, I try to say, you said, oh, no damage. So I try to explain, even without the damage, you will still have like a different coloration due to the density absorption of different particles. Yeah, I just try to explain.
Okay, so the heat deposited by the alternating current then cause the carbon atoms in their molecular structure to some of them to shift from a double bonds to single bonds, so that when light falls on the cloth, these single electron bonds in the carbon atoms reflect light differently than the previous double electron bonds.
That's right. The reason? Yeah, that's because when you're different bond, single bond versus double bond, so now you're oscillating, you're changing your oscillation frequency. So that's why you see different color. Yeah. I believe we agree with this. That's what color. Just another things I just will let you know. Another things you talking about the free electrons away from the in my from my research, there is no free electron whatsoever in atomic model. That's a wrong atomic model by classical physics and probably by modern physics. Say, hey, we have a free electrons orbit nucleus, the center nucleus as atomic model, similar like Niels Bohr's, planetary model. In my research, that's completely wrong atomic model. There is no any free part, any called a revolution, orbiting a center of the nucleus model. Anything have a moving part in the atomic model, that's a wrong model for me. So, but this is my research, okay? So that's why, but that's all right. But what you are described here, I totally agree. This evidence is come from radio. We call that radioactive decay, or from the in my theory, every not just the shroud cover body, every furnitures in your home will imprint your electromagnetic signatures on the object. In my theory, yeah. Because whenever the way you're thinking, the frequency and the different thoughts would imprint, not just the radioactive decay, particle impact, no, just radioactivity, just electromagnetic wave itself would imprint on the body nearby you,
But we
not
don't
only
typically,
on your body.
but we don't
that's my
typically
theory.
see, unless I'm misunderstood, we don't have a lot of evidence of other burial shrouds having this type of image signature on it. Visible
No,
like this.
No, in the billions of people that have lived and died in the history of the earth, this is the only one where we have an image of the person that was wrapped within it. Yeah, I can go into my closet and my dresser and look on the inside of all my clothing. On none of my clothing is my body image registered. And you can do the same experiment. I give you permission. It's safe to do that experiment at home.
Let me tell you, one evidence is, the dog has a very sharp smell, right? So if you are the stuff in your home surrounding you, dog can tell this is something about you instead of something about somebody else. So they have an electromagnetic imprint on everything. Just current technology may only detect one, way this unique one, right, from the Jesus tomb, but may not able to display all other phenomena. But we know these things exist. I just use a dog can tell this one. But you use or somebody else use.
Yeah, but Dr. Yu, how come we don't see 3D images like this in other ancient burial cloths? Thousands of years old, or 1,000 years old, or 2,000 years old. Why don't we have more of these? They've had plenty of archaeological digs. They should have seen something with visible discoloration like this.
Very, very good, very good. The number one is a lot of ancient tomb, uncovered in say over China, right? Most of them are submerged by water. When you open the cover, you will see lots of mud on the watering in it. Of course, you damage the fabric, right? So it has to have a unique.
But there's not in the Middle East. In the Middle East, where Jesus is, where they had similar burial practices, we should see this as a common thing. There's plenty of people looking to discredit it.
Let me make a prediction, right? So far, we do not have. If you spend as much time, effort by research of the Shroud of Turin, if you have this amount, you will find that this is not a unique phenomenon. You have images. I can make that prediction, and I can bet you $10 with you, $1 with you, and I believe. If you spend that much time, with cover, you will find the same, find the image word. This is not a unique case.
You're saying that we should be able to find burial cloths with the visible image of dead bodies all over the place?
If you under similar conditions, yes.
No, but you can see that with the naked eye.
Right.
Yeah. I
believe if you studied the burial case, other than just the Jesus tomb, right? Somewhere else, I think this should not be a unique case.
There's so many people wanting to prove that already. They would have. I mean, I'm sure. I'd love to.
Sorry about
There's
it.
people with a lot bigger budgets ready to bet that there's a cloth
Yeah.
like that already.
You know, yeah, this might be different than a religious view. I'm from a scientific view. I believe based on radioactivity and emission of particles, based on this scientific evidence, that's what Bob tried to demonstrate. So that's why this should not be unique phenomenon.
Yeah, but
okay.
but it's also a scientific evidence to say you have to demonstrate this phenomenon in nature somewhere on a cloth. I haven't seen it. That'd be the great first step. Bob, what did you want to say?
Bob, you go ahead.
Yes, if you think you know of some way to naturally make the images on the cloth, well, then you should be made aware that there's a £1 million offer now. If you can do it and create these full-size front and back images of a person on a linen cloth that is consistent both macroscopically and microscopically with the Shroud of Turin, they will give you £1 million. It's an offer. It's a legitimate offer. No one has even tried to, there's been no proposals.
Yeah, no
to
problem.
win
I
this.
believe because of the cost is significant more than probably $1 million. Yeah.
Yes.
If
I could,
don't you just leave it in a limestone cave for a few years and it'll do it or something? Is that your thought, Dr. Yu, or do you think it takes thousands of years?
No, I believe it needs accumulations.
Like
So if
thousands of years?
this one we can say spend like almost 2,000 years, right? Say say if you can find a similar tomb over 2,000 years under the same burial conditions, and probably you will see very similar pattern. I'm from a scientific part viewpoint. Scientific viewpoint should be repeatable. Yeah.
So there should be a light emission that occurs from all decaying bodies on a
Oh,
cloth.
sure. Oh, that I have no doubt. I have no doubt. You can measure it. Yeah.
Light, so you could visibly see light emitting.
No,
from
no, no.
bodies?
It's not light.
Yeah.
Invisible, called electromagnetic radiation. Yeah, you can measure it. Even dead body, even tree has electromagnetic radiation. Yeah.
Bob,
yes, there was an experiment performed where a dead pig was wrapped in a linen cloth under the right conditions, and they waited to see what they got. And you know what they got?
Nothing.
Flies.
Oh.
No image, only flies.
Okay.
Okay, they've tested that. You're not gonna get an image of any kind of.
Wouldn't they have images like with the pharaoh entombment on the cloths that they use for the pharaohs? No,
Well,
I'm just saying I'm saying if Dr. Yu's theory is correct, wouldn't we see images of the pharaoh's body on the
Sure.
on the wrap?
You never see that. You would only see it if it was painted on.
Because but Dr. Yu, those wraps are on there longer than even the 2,000-year date for this one. Those
Right.
pharaoh tombs go back 3,000 years or so, right? What is it, 4,000? Some of the preserved mummies they have. Wouldn't they have images on them? Or
That's good. Good question. I would think you would find the images.
Well, let's go look and see. We'll leave it there. Bob, do you have any other thoughts or closing thoughts you'd like to share?
Well, yes, I do. For those who would like more information from my perspective on this, please go to my website, shroudresearch.net. My last carbon dating paper was my paper 33. If you go over on shroudresearch.net, go to the third page over, which is my research page. The papers are listed in reverse order with the newest on the top. Go to paper 33 is on carbon dating. Paper 34 is on image formation.
I appreciate your time. And the website again, for those who want to go to your website?
shroudresearch.net.
Very good. Dr. Yu, any final thoughts?
Very good research, and you use scientific method and dated much accurate than anybody dated before, which I have no doubt. Your results is solid, and just say how to interpret the results is maybe a little bit different.
Well, Dr.
great
Yu,
work.
that's homework we got to do. I want you to find me an image like Pharaoh with the wraps where we see the image
Yes.
imprinted. That'll be, if you bring it to me, we'll look at it. Okay.
And so I don't need a $1 million reward. Okay.
Well, you
I
should
just
get it.
need a
That's a great
$1
bonus.
award. That would be good enough. Okay.
All right. Thank you for your time. I know
Thank you.
we covered a lot today and it was very technical, but I hope that it was of value for folks. I think it was for me as well. So thank you, sir, for your time.
Thank you.